Okay, let's move on to 1.7 linear independence. Definition. Okay, what's that mean? Linear independence. So a set of uh vectors, say v1 and vp, vn, and these are vectors. So it is a linearly independence. Independent. Okay. If the equation x1 v1 plus x2 and a v2 through the vn xn vn. So x1 through the xn are coefficient. Okay, here. Simply, you can say this is sigma. You can express this one in short using sigma notation. So I equals 1 through the n, and then xi, and then vi. Right? So this is equals 0. Has only the trivial solution. I think this is so it means that what? It means that x1 through xn are 0. x1, x2 through the xn equals 0. Okay. So otherwise, if there is a choice to make this one to 0, other than 0, then that must be not linearly dependent. Okay. So it means that if there exists, that means there exists. That's a mathematical symbol, there exists. If there exists uh, xi, which is not equal 0, such that x sigma and then I equals 1 through the, let me use it j. Okay. And then for some j. Okay. I was 1 through n and then xi and then vi is equal to 0. Then what? The system is linearly dependent. Ooh, let me write that here. The system is called the linearly dependent. Okay. Here example. Let's see example. Here's the example. So think about this. This is 1, 0, 1. Okay. And then 2, 1, -1. Okay. And 4, 1, 1. Okay. So let's say this is V1 and this is V2 and this is V3. So is this set is linearly independent? Let's figure it out. Okay. What are you gonna do? If this is what linearly independent, then considering these vectors as a column vector matrix, okay? So let's say we construct A as V1, V2, and V3, okay? And now we're gonna solve the equation AX equals 0. If this one is a homogeneous system, right? So if this homogeneous system has only the trivial solution, then this set must be a linearly independent. It makes sense? Because think about this, where A comes from? A comes from these vectors, V1, V2, V3. Okay. So now homogeneous system has only the trivial solution, which means the x bar must be only zero, must be zero. None of value can be a solution. So there is no non-trivial solution. So x bar must be zero to get zero by multiplying a, which means that, you know, I mean, a x bar equals zero vector is if and only if what? X1 times v1, right? Is it? Plus x2 v2 plus x3 v3. We did that. Ax bar, sorry, Ax bar equals this, right? So this is a what? Linear combination of vectors. So you should be familiar with the other expression of the matrix equation. Matrix equation can be, written as, linear combination of vectors. Okay. So this is equals zero vector right here. And then solving this system is nothing but, solving that vector equation. So, and then this homogeneous system has only trivial solution, which means that in here, vector equation, x1, x2, x3 must be zero. It means that what? v1, v2, v3 must be linearly independent. Okay, so now we do what? So guess what? We have to find the REF or EF. Okay, so A is this, and in the augmented matrix is gonna be 1, 0, 1, and 2, 1, -1, and then 4, 1, and 1, and then 0, 0, 0, and then do EF. Applying the elementary operations, and then blah blah blah, and then we got 1, 0, 0, and 2, 1, 0, and then 4, 1, 0, and then 0, 0, 0. Wait, what happened? Sorry. So since you see that here, we got the zero row, only two pivot positions right there. There's a pivot positions here. This is a pivot position. Okay. So what's a pivot? Actually, this one and this, right? Okay. So what this guy has a one free variable. It has non-trivial solution, so linearly dependent. Got it? Because this is a free variable. What does that mean? That homogeneous system has non-trivial solution, which means that x1, x2, x3 can be, can be a certain non-zero value. Right? Okay. So now the system homogeneous system has a free variable. Actually, x3, right? X3 is a free variable. So there exists. Okay, since that means there exists. Okay, there exists non-trivial solution. Okay, to ax or equals 0. Thus, the set of v1, v2, and v3 is linearly dependent. Okay, so actually what? Look at this. X1 is -2 times -4x3, right? From here, let's figure out what's the relation between v1, v2, v3 by figuring out x1, x2, x3. Okay, so you don't have to do that. This is done. This is the answer for the solution for that problem. So I just want to figure out the relation between v1, v2, v3. Okay, so here x1 going to be -2 x2 and then -4 x3, right? And then x2 is minus x3, and then x3 is just 3, right? So it means that x bar, because to figure out the relationship between v1, v2, v3, we need to figure out parametric, parametric vector form of the solution. So x1, x2, x3, this is equal to minus 2 times, sorry, x2 times, right? Minus 2 times 0 and a 0, and plus x3, then minus 4, and then minus 1 and 1. You see? You see that? Oh, really? Mm. Oh, can you say again? Oh, yeah, yeah, right. So this should be just uh 3. Yeah, this is right, right? Oh, no. Oh, yeah, this is equal to plus 2 times minus 2x3, right? Sorry. So we okay, this is minus 2. Now, right, right? Yeah, this is right. Hmm. Okay. So when x3 equals 1, let me put the 1 into x3. Then when x3 equals 1, then x bar gonna be -2, -1, and 1. Okay. So this one make this one to be 0 vector, which means that that is the solution of the homogeneous system, which means that, yeah, I mean, so from here, what? That can be used as evidence that what this is linearly dependent. Okay. So simply saying that -2 times, so it means that what -2 times v1 minus v2, the plus v3 is equal to 0. Right. Okay. But not only that one, what? Let's say this is the vector of what? -2, -1, and 1. Sorry, like this. Okay. Then the line through that vector is the solution set of that homogeneous system, actually. Okay. Okay, so now next one. So here we can see that what? Here's a fact. So the column of matrix A, okay, are linearly independent. Okay, if and only if AX bar homogeneous system has only a trivial solution. Okay, now you can see that, right? Okay, then here's a question. Okay, here's a question then. Is the set contains only 0 vector, linearly dependent, linearly independent, sorry. Answer. What do you think of the answer? Do you think the answer is yes or no? Why? Yeah, for example, because x1 times 0 vector equals 0, x1 can be any number, right? So, ooh, linearly dependent. Okay, sorry. Yeah, so for any x1 in R. Other question then. Okay, is the set This one, linearly dependent. Ooh, linearly dependent. If vector v is not equal to 0 vector. What's the answer? Once you figure, if you figured out the answer for the first question, it's easy to figure out the answer for that question. Well, the answer is what? Yes. Why? Because x1 times v equals 0 vector. Since v is non-zero, right? V is a non-zero vector. Non-zero column vector, I mean. So only if, well, x1 equals 0. I'm sorry? Linearly, give me a second, hold on a second. Let me give the three useful theorems for determining if the set of vectors linearly dependent or independent, whatever. So theorem, I think I forgot the theorem number, but just let's say it's theorem 1. Okay. So a vector, well, a set. Okay, sorry, a set of two vectors. So v1 and v2. See, is linearly dependent. Okay, if and only if. It means that linear dependence means that what? We saw that in here. The two vectors, I mean, three vectors have a relationship, right? So likewise, if one vector is in here, one vector is can be expressed as the scalar multiple of the other vectors, then that set must be linearly dependent. So, and this, I mean, one of vectors. Oh, one vector is a scalar or just multiple. Either one doesn't matter. Scalar multiple of the other vector. Okay. Actually, another, right? Of the another. And then next one, theorem 2. Theorem 2 is this now next one, give me a second. What's theorem number? I forgot. Oh yeah, okay. Oh no, I forgot the theorem number. Okay, if you vector u and v is linearly independent, then what does is this is linearly independent? So that means what? The homogeneous system has only trivial solution, right? And also u and v cannot be expressed as a multiple of other vectors, each other, right? So the other vector w is in the span of u and v. Okay, keep in mind is u and v, this set is linear independent. So you cannot be expressed as multiple of v and then vice versa. Okay. And the w in the span right there, if and only if u and v and w must be what? Linearly dependent. Okay, why? Because W can be expressed as what? Linear combination of U and V, because W is in span U, V. Okay. So let me generalize this. Generalize this, you get this. Um, so assume that U1 through the UN is linearly independent. Okay. Then what? W is in, or UN plus one, sorry, N plus one is in span U1 through the UN. Okay. Then what? Then U1 through the UN plus one is linearly independent, linearly what? Dependent, right? Dependent. Okay, let me express this one in other way using matrix. So let's say, other view, let's say A is the, like this, U1 through the UN matrix right there. Okay. So now then, AX X bar is equal to zero vector. Homogeneous system has only a trivial solution. It means that what? U1 through UN are linearly independent, right? If and only if what? A and the other vector UN plus one, okay? So we add one more column, UN plus one into matrix A. So this is actually, let's say, is M by N. Now this is going to be M by N plus one. This matrix must be, I mean, all columns, set of columns of this matrix must be linearly dependent, so that A UN plus one bar, and then X, me not X, let's say Y, okay, Y bar is equal to zero vector. This one has non-trivial solution because it has free variable. You see, so you kind of back and forth. You need to understand the this way, that way, okay. And then next one, theorem. This is theorem 2, theorem 3. So, yeah, from here we can we can build up the theorems from there. There's a theorem 3. So, so if a set has more vectors than entry, in each vectors, okay. If a set has more vectors than entry in each vector, what does that mean? Number of columns is greater than number of rows, okay, in matrix, okay. I mean, considering this one, you know, this set, I mean, the vectors, considering the vectors as a column vectors, a matrix A, then that means a set has more vectors than entry in each vector, means that the number of columns is greater than number of rows, okay? Then what? This is what what we got in here, right? Then what? The set is linearly independent, dependent. Then the set is dependent. Sorry, I just skipped to writing linearly, okay? Is linearly dependent. So it means that what? So in Rn space, Okay, so we got vectors. We have vector p vectors. Number of vectors is p. Okay, is linearly dependent if what p is greater than n. So what is the p? Here p is the what? The number of columns. N is what? The number of rows. Other ways, number of rows is what? Number of unknowns, right? Unknown variable. And the number of column is what? Number of equations. Okay. So number of equations is greater number of unknowns variable. Oh, sorry, is a number of this is no sorry, this is a number of equations, right? Sorry, that must be right here. And then this guy must be right here. Then this is right. This is right. Okay. So number of unknowns is greater than number of equations, then definitely we're gonna get free variable. So we got free variable, then what? Dependent. Because the homogeneous system has non-trivial solution. So all matrix system are homogeneous, trivial, non-trivial, and then linear dependent in them connected. These are connected. Okay. So give me a second. That's the summary of 1.7.